today we're going to talk about how to find area of a triangle. Okay, so let's say you've got a right triangle. All right, so you've got just one of the angle measures is 90 degrees. How do you find the area of that triangle?
That's half base height.
Half base times height, where one of the sides is the base and the other one's the height. Doesn't really matter which one is which. Yeah, so area equals 1/2 base times height. All right, any questions? So you guys already know this one. Yeah, this one's pretty easy. But this unit, we're not really too interested in right triangles. I mean, we kind of use them to take advantage of some of their properties when we're dealing with oblique triangles. But really, we're talking about oblique triangles. So let's say we've got an oblique triangle, meaning one of there's no right angles. So let's say we've got a side angle side. So we've got some triangle which is not a right triangle. And we know, let's say, this angle's A, which means this is side A. So we'll say this is side B and C. Any idea how we might calculate the area of this triangle?
We always do 2 1/2 base times heights. We're using the height on either side.
Yeah, we can use 1/2 base times height again, but the height's not given here. So how would we calculate the height, which is like right here? All right, we do want to do 1/2 base times height, but since we don't really know what the height is, that's not going to be something that's given. How could we calculate that?
C sine A.
Yeah, so since the height is going to be C times sine A, and we had to deal with that a little bit in some of the triangles we've talked about, we can replace that H with how we calculate it so that we don't have to actually calculate it separately, and that's going to be times C sine of angle A. All right, so this one's pretty obvious. It's not so bad. What if we're not given that angle, though? So let's say we're given all 3 sides, okay? So if we're given all 3 sides, we're going to use what's called Heron's formula. Good old Heron figured this one out. And if we got time, which we might, we could go through the proof if you're interested. It's sort of a weird one. I don't think it's very intuitive. But so let's say we've got a triangle. We'll call it ABC. Okay. So Heron's formula looks like this. So I'm just going to give you the formula just right off the bat. There's going to be one variable that I'll have to sort of explain. But here it is. The area equals the square root of a product of 4 numbers. Okay? So the 4 numbers that we're going to be writing here are going to be something called the semi-perimeter, which is something you probably have not talked about. I'm going to call that S. So what the semi-perimeter is it's half of the perimeter. So it's kind of exactly what it sounds like, semi-perimeter. It's just half the perimeter. So I might make a little note over here to say S is the semi-perimeter. So in other words, you have all the three sides, you just calculate what the perimeter is and just divide it by 2. All right, so S is A plus B plus C divided by 2. So you'll have to calculate that up front. So I said we're going to multiply 4 things, right? Well, one of them is the semi-perimeter, and then the other 3 things are the difference between each side and the semi-perimeter. All right, so in other words, you would have something like the semi-perimeter minus A, the semi-perimeter minus B, the semi-perimeter minus C. And then if you multiply all those 4 numbers, take the square root, you'll get the area. Now, as long as you can memorize this formula, you should be able to find the perimeter every time just plugging all the numbers in at that point. So we'll do some examples together. Anyone have any questions so far? All right, so let's do a couple of examples here. So in all these cases, we're just finding the area. So let's say you've got some triangle where you know one of the angle measures is 109 degrees, and the 2 adjacent sides are, let's say, 52 and 90. And I want to find the area here. So this is a side angle side scenario. So we can go with that middle formula we came up with, which is really just an extension of the classic half base times height formula. So the area will equal 1/2 times the base, which in this case is 90, times the height, which we had to calculate out, and so we had another way of writing that, right, which would be 52 times the sine of 109. So this right here is just the height being calculated. Just keep that in mind. And at this point, you just throw all that in the calculator. So the area is going to be about, sine of 109 is going to be a little less than 1. So that'd be like 50 times 90, 45, so I don't know, like 2,000 something probably.
2,212.
All right, so about 2,200, and what did you say, 12? Is that what
It could be 13 if you round it up.
So what's the first decimal?
5. So
Okay, so yes, we'll say 13. And if those are square units. I didn't give you any units, so we'll just... All right, so let's do another one. Here we're going to have to use Heron's formula, although some textbooks call it Hero's formula. I don't know why. It's a little bit more fun, I guess. So here's, let's say this is 43, 53, 72. I'm just making up numbers here. So we've got this triangle. So we're going to use Heron's formula to calculate the area. So the area here would be the square root. I'm just going to rewrite the formula here. It's the semi-perimeter times the difference between the semi-perimeter and each of the 3 sides. So the semi-perimeter minus A, the semi-perimeter minus B, the semi-perimeter minus C. So what might be kind of smart to calculate here is the semi-perimeter, right? Like let's maybe calculate that up front. So the semi-perimeter is going to be, so I add up all the sides, 43 plus 53 plus 72, all divided by 2, so it's half the perimeter. Oh, okay, thank you. So yeah, what is the semi-perimeter? What'd you say? 84? Okay. So just calculate that out to the side. And now we just start plugging stuff in. So the square root of 84 times 84 minus, and I didn't name any of the sides. It doesn't really matter which one you pick to be what. you notice all of these are basically you're doing the same thing, right? You're just taking the 70 perimeter, subtracting the length of the side. So I'll just go smallest to largest here. 43, 84 minus 53, 84 minus 72. And you really could put all this in the calculator at once if you'd like. I'm just going to take it a little slow here. So this would be 12. No, that would be 41. So times 41 times 31 times 12. And so what is our area here? Sure, we'll round to the nearest whole number. So 30. All right, there you go. All right, any questions about these area formulas? Yes, sir.